Here are two ways to sort the exact same list of numbers on the exact same computer. One of them does 1,000 times more work than the other. Watch the counters. Bubble sort is the one most people invent on their own. Walk along the list and compare each pair of neighbors. If they are in the wrong order, swap them. The biggest number keeps winning, so it bubbles all the way to the end. But that was just one pass. To fully sort, you repeat the whole walk for every element in the list. A loop inside a loop. The work grows like n times n. We write it as order n squared. Remember that number, it's the whole story. Quicksort is cleverer. Instead of comparing everything to everything, it divides the problem. Pick one number as the pivot. Then split the list into two piles. Everything smaller goes left, everything bigger goes right. Now do the same thing to each pile, and again to each smaller pile. Each round only compares against one pivot, not everything. Dividing in half each time is the magic. The cost is only order n log n, and log n is tiny. Here's why it matters. Let's plot the work each one does as the list gets bigger. At first they look the same, but bubble sort's curve bends upward, squaring n, while quicksort stays almost flat. And that gap between them just keeps growing. Put real numbers on it. For 100 items, nobody cares, both finish in a blink. But at 10,000 items, bubble sort already does 100 million comparisons to quicksort's 100,000. And at 1 million items, it's 1 trillion versus 20 million, the difference between hours of waiting and the blink of an eye. Same sorted list at the end, wildly different costs to get there. So 3 things to remember. 1. Bubble sort compares every pair, which is order n squared. 2. Quicksort divides the list in half, which is order n log n. And 3. Once your data is big, the algorithm you choose matters far more than how fast your computer is. Next time, what a 3D convolution actually does, the operation behind every image model. Subscribe so you don't miss it.